Hello everyone, welcome to our new video. We are Team 30 and today we're gonna make different gates with my teammates. My name is Suat Hamzali, by the way.
Hello, my name is Shakir Badalzadeh and today I'm going to create a NOT gate.
Hello, my name is Mohammed Sheikhov and today I'm gonna construct the AND gate.
Hello, my name is Arif Kadalov. Today I'm gonna make an OR gate.
So let's get started.
First of all, we plug in the battery or power supply to the breadboard. This gives our positive and negative rails. The red line is plus and the blue line is ground. Next, we add our resistor. We use a resistor because we don't want too much current to flow, otherwise the LED could burn out. Then we place our LED. The longer leg of the LED goes to the positive side and the shorter leg goes toward the negative side. Now we connect the resistor and the LED together, so current can flow through them in series. After that, we connect the other end of the LED to the minus rail. That's our ground connection. Now, if we power this part directly, the LED would light up. Now we place our NPN transistor. The transistor has 3 legs: collector, base, and emitter. We connect the emitter to the ground, the collector to the LED's positive side, and the base will be our input. We will control it with a button. Next, we place a push button. One side of the button goes to the positive rail, and the other side goes to the base of the transistor through a small resistor. This resistor protects the transistor just like we protected the LED before. When we don't press the button, the base doesn't get voltage, so the transistor stays off. That means no current flows and the LED is on. But when we press the button, the base gets power. The transistor turns on and it pulls the LED side down to the ground, turning the LED off. That's why it's called a NOT gate. When the input is on, the output is off, and when the input is off, the output is on.
First of all, we plug in our power module to the breadboard. That gives us power on the red line for positive and the blue line for ground. Next, we add our resistor and LED. We always use a resistor with an LED so it doesn't get too much current and burn out. We connect the resistor and LED in series. One side of the resistor goes to the positive line and the other side connects to the LED. Then we connect the other leg of the LED down to the collector of the last transistor. Now we add 2 NPN transistors. These will work together to form our AND logic. We place them one below the other. Each transistor has 3 legs: collector, base, and emitter. The emitters of both transistors are connected to ground. That's the blue line. The collector of the first transistor goes into the collector of the second, forming a chain like a series connection. Now we place 2 push buttons. These will be our inputs, input A and input B. Each button connects to the positive line on one side, and the other side of each button goes to the base of its transistor through a resistor. These resistors protect the transistor bases from getting too much current. Now let's understand how this works. For the LED to turn on, both transistors must conduct. That only happens when both buttons are pressed, meaning both bases get voltage and current can flow from the LED through both transistors down to ground. If even one button is not pressed, one transistor stays off, breaking the path so the LED stays off. Let's test it now. When I press only the first button, nothing happens. When I press only the second button, still nothing. But when I press both buttons at the same time, current flows through both transistors and the LED lights up.
First of all, we plug in our battery or power module to the breadboard. That gives us our red line for positive voltage and the blue line for ground. Next, we add our resistor and LED. We use a resistor because we don't want the LED to burn out from too much current. We connect one side of the resistor to the positive line, then connect to other side to the LED. Finally, the LED's other leg connects to the collectors of our transistors. Now we place two NPN transistors. These are going to work together to form our OR gate. Each transistor has three legs: collector, base, and emitter. For the OR gate, we connect both collectors together and link them to the LED. Then both emitters go down to the ground line. Next, we add two push buttons. This will be our inputs, A and B. Each button connects from the positive rail to the base of one transistor. We also add a small resistor on each base so we don't send too much current into the transistor. Here is how this circuit works. If either one of the transistors turns on, current can flow through the LED to ground. So when we press any one of the buttons, the LED lights up. And if we press both buttons together, it still lights up, because at least one transistor is conducting. The LED only stays off when both buttons are released. Let's test it now. First, I will press button A, the LED turns on. Now I will press only button B, the LED also turns on. And if I press both buttons together, the LED is still on. That's exactly how an OR gate works. Output is on if any input is on.